Okay, morning guys. So this should be the last part of differentiation where the book talks about motion of a particle. So all they're doing is just relating what you already know about differentiation and just applying it to motion. So that would be displacement or distance, whichever you want to name it as, velocity or speed, and acceleration. So they just want you to relate it to that. So instead of y, they usually use s for displacement, and instead of x, they usually use t. So you'll see a graph where this is t and that is s. So instead of dy over dx, you would have ds over dt. Okay, so this would be my displacement. The gradient is the speed or velocity, and then if you just differentiate that again, that then becomes the acceleration. Most of the time you won't really touch acceleration, but it is good to be aware of it. If you are looking at further maths or A-level maths, you'll be seeing this one a lot more where they do the second differential and you have to start thinking about types of turning points and everything. But for now, all you need is distance, speed, acceleration. So if you can't remember what it's like, so this would always be meters, this would be meters per second, and this would be meters per second squared. So you can see you're only going to do it by once, so time is in seconds, so it's per second, and then you've got time second differential, so you've got second squared, okay? These kind of units always help me out to know how to find these out, so I don't know if you want to relate it, it might help, it might not, but it's all up to you. So we are going to just go through a couple of examples. So it says a bike travels along a straight line, its displacement from its starting point 0, origin, so if they were doing it from a graph, it would be origin, after t seconds, where it's got the equation 4t plus 3t squared take away t cubed. Okay? And then what they're asking you to do is to find the velocity and the acceleration at time of 2 seconds. Okay, so first of all, to find the velocity, I need to differentiate this. So 4t becomes 4, 6t squared, the 2 comes down, so it becomes a 6, and you drop a power of the t. And then this one, the 3 comes down, and you drop the power, so it becomes a 2. Okay, this would be my velocity. They want it when t equals 2. So when t equals 2, that's 4 plus 6 times 2, take away 3 times 2 squared. So 4 plus 12, 3 times 4, take away 12. So that cancels out, and that becomes 4 meters per second. Okay, and then for the acceleration, you just have to differentiate this again. So the 4 becomes a 0, the 6t would then become 6, and the 2 would come down to make a 6, and you drop the power, so it becomes 6t. Okay, and when t equals 2 for this, you have 6 take away 6 times 2, which is 6 take away 12, making it negative 6 meters per second squared. Okay, so because it's negative, you know, it's decelerating. So if they do kind of ask you to make any kind of commentary, you would probably say it's decelerating or it's slowing down. Okay, this is just giving you the speed at that exact moment in time, and this is giving you the acceleration at that exact moment in time. So it's going at 4 and it was slowing down from a previous speed, whatever that speed was. And that should cover you all for that question. Okay, so for the next one, they are talking about someone on top of a cliff throwing a pebble or something. Right? Yeah, a pebble. So imagine there's my wonderful cliff. Here's someone, whoever they are. They took a pebble, they threw it up in the air, and then it comes back down. So what do I notice about that? You will probably notice that it is a parabola. They do tell you that S is 10t take away 5t squared. So you are expecting some sort of negative quadratic because the highest power is a square. So I am expecting a negative parabola. So this is kind of what I'm expecting. Okay, and what they're telling you to do, so they're saying find the maximum height. So the maximum would be this. So when it's maximum, ds over dt would equal 0. So I need to find out what ds over dt is, which is the first differential for this. So 10t then becomes 10. This 2 comes down, 2 times 5 is 10. T drops a power, so it becomes 10t. And I've already confirmed that the velocity would be 0 at the maximum. So it would be 0 is 10, take away 10t. You rearrange that, that becomes 10t equals 10. T then equals 1. And because time is in seconds, I'm going to say that is 1 second. Okay, so they said find the maximum height reached by the pebble when this occurs. So, maximum height is obtained at 1 second. They've told me that this is how I can find the displacement. So now I need to pop this into this wonderful equation. So S is 10 times 1, take away 5 times 1 squared, which is then 10, take away 5, which is 5 meters. So because it's displacement, that positive would be this way. So that means this height to the maximum height is 5 meters. Okay, so hopefully that answers, well, it goes through some of the stuff. So all you're doing is applying the differentiation that you have. Do let me know if you have any questions. There is exercise 5 that you can already see here, and there is a 5-star. So obviously start on 5 if you just want to go for a little bit basic and just make sure that you can apply, and then 5-star if you just want to try something a little bit more challenging. I know a lot of you don't seem to remember your password for Active Learn, so I will just be popping the pages, and I'll take a copy of the pages and I'll attach them to the assignment. Okay, take care guys.